Hello all, welcome back. So in the last video, we have learned what is pin jointed plane frame, perfect, deficient, redundant frame conditions, and what are the assumptions we take while we analyze a frame and different method of analysis of a frame. So in this video, we are going to study about these two topics, method of sections procedure and one example on that so you could understand clearly. So these are the procedure. For an assumption, you take this is as 750 Newton and this one as 540 Newton. And these are two reactions from the support called A. Here it's B, C, D, F. Two reactions is happening here in this direction. So if we follow this four procedure, we can solve any truss or a frame using method of sections. The first step is mark the unknown force. For example, you fix these are the unknown forces, and these unknown forces should be less than or equal to 3, as I mentioned here. Yes, 3 here. Then step 1 is okay, completed. And calculate reaction forces. There are two reactions happening here, RA and RB, that acts upward. These reactions happens because of this two forces acting here. So I'm just applying the equilibrium equation. Vertical forces are equal to 0. Summation of vertical forces should be 0 to be in equilibrium. So RA, which is in upwards, plus RD, sorry, RB here. This is RB, that is also in upward direction, plus this is in downward direction, that is 750 Newton, and this is also in downward direction, that is 540 Newton, should be equal to 0. So RA plus RB equal to 1290 Newton. This is the equation 1. Then you take moment about A. If you take moment about any point, it should be 0. Then only it could be in equilibrium. So moment of A should be 0. So you take moment from here. There is 750 Newton is the first force. So which is acts in a uh, counterclockwise, sorry, clockwise. So it should be plus 750 into distance, that perpendicular distance from the force, that is 2 meter. And another next force is that is also clockwise, so plus 540, and the perpendicular distance is 5 meter. Then the third force, that is a reaction, happens here, this direction, that is 7 meters away. But if you see that this is counterclockwise, so we take it as a minus RB into, we don't know the force, so we keep it as a RB only. So distance is 7, that should be equal to 0. You solve this thing, can get 1500, can get RB value as 4600 Newton. So if you substitute this RB value in equation 1, you can get RA value. So RA into 600 equal to 1290 Newton. So RA equal to 690 Newton. So the step 2, the calculation of reaction forces that we calculated. Then separate truss into two sections by drawing a line. of joining unknown forces. Three unknown forces, we are joining that line, and then we can divide into two. This either we can take on the right side of the this line or the left side of this line. I'll give different colors so that you could identify. So you can take this right side of this green line or left side of this green line. So I think I can take the left side. Okay, then you can get a figure like this. One reaction force, an external force, and three unknown force. We can call it this as F1, F2, F3, three unknown forces. Initially, we take it as the force that is moving away from the point like this for calculation F1, F2, F3, and we know the two support reaction. So RA is 690 and one external force 750 Newton, and this distance is 2 meter and this is 3 meter, and this F3, if you see this F3, it has only component in the horizontal direction because it acts on the x-axis, same as F1. And if you take F2, it has two components like F2 sine theta and F2 cos theta. If this is a theta, means it has two components F2 sine theta and F2 cos theta. So yeah, this is step 3, and we need to find the theta also here. What should be the theta? You can go to this here, that this is a theta value. So you know this is this distance, this member uh, length, that is 3 meter, and this also 3 meter. So if you apply tan theta, which is equal to opposite this member 3 meter, and adjacent this is also 3 meter, so tan theta is value equal to 1. So theta means tan inverse 1, the value is 45 degree. So this value is okay, this value is 45 degree. So now we can completed the third step, so we can move into the fourth step, that is apply equilibrium equation. Equilibrium equation is nothing but summation of f of x equal to 0, summation of f of y equal to 0, and moment about any point should equal to 0. So these are the equilibrium equation. Now we are going to apply this equation here to find the F1, F2 and F3. If you look at this diagram, you could see that two vertical forces are acting, and these two have horizontal components, and this have one vertical component, that is F2 cos theta, cos 45 degree. So these two, since we know these two vertical forces, if we apply this summation of vertical force equal to 0, means we can find the one force, that is F2 cos theta. So it means 619 upward direction, so plus, and 750 is in downward direction, so minus, and F2 cos theta also in downward direction, so F2 cos 45 degree, which is, I'll solve it in the next step. So this might be minus 60 minus F2 cos 45 degree is 0. So 1 by root 2 equal to 0. So from that we can find F2 is equal to 60 plus, sorry, 60 into root 2. But in the minus value, this minus value indicates that this is compression force acting on the F2. So compression force means, as we know, the direction should towards a point. That point here is, what is the point? F. So direction of the F2 force is this. So we can cancel this thing. Okay. So F2 value is equal to 60 root 2 compression. Then what should we do means, now we applied this formula, that is vertical force summation is 0, and now we can apply the horizontal force value. But here we can't apply that because there is only, sorry, the unknown horizontal force values are 3. You see that F1 has horizontal component, F3 has, and F2 also has F2 sin theta. So this won't be, not suitable for here. For example, if it's have only one unknown means, and we have another force acting, means external force acting on means, we can at that time we can use that. But now it's not suitable for here. So we just moving into moment. We can take moment about any point in this diagram. So we can take it from here, 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 anywhere. But it should give us a less step to find the answer. So I'm going to choose here. Why? Because if I choose here, this force would get eliminated because its origin is here. So I can eliminate this. Why? Because means I'll explain here. From the point, we take F1. What is the perpendicular distance between this force and this point? That is 0. Because if the F point is here, this would be perpendicular. Since it lies on the same point, the perpendicular distance would be 0. So if you take moment, this force get eliminated. The same way F2 also get eliminated because it has two components in this points only. The only thing I have is F3, the unknown F3. So if you take moment about point F, you can get F3 which acts in this direction, which is counterclockwise. So take it in minus. So F3 into the distance should be 3, this distance. So next, I have this also lies in the same line. If you see that, lies in the same line. So there is no perpendicular distance. So it would get cancelled. And another force I have is 690, which acts in, according to this point, it is clockwise. So plus 690 into the distance should be perpendicular distance 2 meter, should be equal to 0. So if you solve this equation, you can get F3 value as, okay, you can get 230, 460, 460 Newton plus. So it denotes it's a tension acts here. Okay, now we found F2 and F3. Then only thing we remaining is F3. So now we can use the summation of f of x, because how, let's check how many horizontal forces you have. 1, 2, 3. Now we know the two forces, F2 and F3. So now we can find the F1 value. So F1 towards right. So I consider as a plus, and F3 also right. So I consider as a plus, and this one towards point. So if you take this is F2. Okay. sorry, this F2 has a components like this because it's before we find the compression assumption. So since it's a compression, this F2 has this thing, two components. This is F2 cos theta, this is F2 sin theta. So here would be F2 sin theta. I hope you would understand because this oh, this figure is before finding the value. Since the compression, the direction has changed, so the two components would be like this. So it should be equal to 0. So F1 we need to find F3 460 plus minus F2 is equal to 60 root 2 plus sin theta sin 45 degree, which is nothing but 1 by root 2. Okay, so these two gets cancelled and F1 value is equal to mm, plus 400 equal to 0, F2 equal F1 equal to minus 400. So F1 is 400 Newton in compression. So we found all three forces by using the method of section. So I'll explain the procedures once again. First mark the unknown force and calculate the reaction forces, then separate into two sections, then apply equilibrium equations. So that's what we did. We first mark the force and green line, and then we calculate the reaction forces, and we separated this stress into two by this green line. Then we applied equilibrium equation as per our desire, so we can get easy steps. So that's what we get. I hope you would understand everything. I expect your comments in the feedback. Thank you.